All right, good morning. So this question is from NCRT model paper given on NCRT website. The question is on LC oscillation and the comparison of an LC oscillator with a spring block system. That question is, how do you compare the potential energy and the kinetic energy present in the spring block system with that present in the LC circuit? So let's discuss what is the analogy between the two situations, the spring mass system and an LC oscillator. How do they compare? Okay, so let me just first draw an LC. So this is your capacitor. Okay, this is your capacitor and it is fully charged, right? So you do charge it and then you remove the battery and then you connect it to the inductor, right? So I'm just drawing the diagram, just have a look at it and you should be able to understand what is being referred to. Okay, so this is your inductor. So this is a fully charged capacitor. Okay, this is a fully charged. Now if you compare this to let me just complete the circuit. This is a complete circuit. Now let's compare this to a spring block system. So I will just draw a block and this is my block. Okay, and this is connected to a spring. So let's say I connected to a spring. Okay, this is the situation. It's lying on a floor. Okay, it's a frictionless floor and it is connected to a spring and it is so see in so this is a spring mass system, right? This is your spring mass system. Now I told you that the capacitor is fully charged. Capacitor is fully charged. The equivalent situation in a spring block system is that the initial position of the mass is when the stretching of the spring is maximum. So the whole energy is stored as a potential energy and is referred to as half kx square, right? And similarly, when the capacitor is charged, the complete energy is in the form of electric field. I will tell you why this happens. So right now the whole energy is half q square by c and is stored in the form of electric. So the equivalent of this is the complete energy and the velocity is zero. So you have the spring is pulled to maximum. It is at a maximum position from its mean position and the complete energy is stored in the spring in the form of half kx square. Now if you notice, this energy is the potential energy, the spring potential energy. This is your potential energy. There is no motion involved in situation which I've just shown you. There is no motion of the block. So the block is stationary, right? The block is stationary. Or so to say, the mass is not moving. Similarly, if you notice the diagram on the left hand side, which is the capacitor, which is fully charged, no charge is moving, right? No charge is moving in the circuit. No charge is moving or flowing, you can say, in the circuit, right? So and same is true for, so the mass and the charge q are analogous to each other. Since there is no charge flowing in the left hand side and there is no mass which is moving on the left hand side, these are equivalent. So the potential energy which is stored in a spring block system is equivalent of the electric field or energy or electric stored in the form of electric field which is stored in the capacitor. So this is analogy between the capacitor with and the potential energy. So okay, this is one analogy. Second, let's say now that you have connected, you complete the circuit, what happens next to the charge? Now the charge will start flowing. The charge will start flowing, and I will show you what finally will happen as the charge starts flowing. What will happen is the complete energy, and at that point of time, the current is maximum, and the complete energy therefore is stored in the inductor. So let me just show you what happens now. Now let me just draw this diagram. So this is your diagram, and this is your capacitor. Okay, this is your capacitor. Let me just complete the diagram so that you can understand. Sorry, I think we have reached the all right. So this is your circuit when the charge is moving now, and it attains the maximum value in the circuit. So this is your capacitor, and this is your capacitor, and now there is maximum current, which means the rate at which the charge is flowing is maximum, and the complete energy is stored in the inductor, right? So energy in an inductor is obviously inside it in the form of magnetic field. So the complete energy is stored in the form of magnetic field, okay, which is your B. And the charge on the capacitor at this point is 0. Now, if I were to draw an analogous situation here, this is what happens. So let me draw the right now. If you notice, this is your spring, and then what you had was a block. So I'll just draw the block, and this is your block, okay, lying on the frictionless surface. And this is the initial position, as you can see above. But when it comes to the situation on the left hand side, and we have to draw the analogy, now the block is no longer here, okay, the block is not here. The block has reached its maximum velocity because the charge has reached the maximum velocity of its, which is the maximum current in the circuit, right, which is dq by dt, right? So this is the maximum velocity of the charge, and similarly the block has reached the mean position, which I'm just drawing. Okay, let me just draw it correctly. So this is the size of the block. Okay, ignore that line which you see, and it starts from here, and this is your block. Okay, and now the block has highest velocity, V max. Okay, V max, which means the complete energy of the spring mass system is converted into kinetic energy, which is half mv square, right? And this is kinetic energy, right? So if you notice, now the charge is also moving very fast, attains a maximum speed. The complete energy is stored in the form of magnetic field, which I have already mentioned. So the kinetic energy is analogous to and the energy in the inductor. Okay. Now what will happen in the next step? Again, the spring will reach its compressive stage, which means the spring block system, the block which is started from rest here, which is what we discussed as a situation number A. Now the situation number B is being referred to because in situation number B, the block is at maximum velocity. Now the block reaches the situation number 3. In the situation number 3, again the block will come to a stop, but now the spring is okay. Let me just draw the spring also. I think I've forgotten to draw the spring here. But now the spring in the situation number 3 will be compressed maximum, right? It will not be at the mean position. Like in the situation number B, the spring is in the mean position. It is still moving rightward once you left it from its, the maximum elongation part. So here the spring had X max, right? And then you left it, it started moving towards the right. The spring pulled it and then it reached the mean position where the velocity is maximum. And similarly here, the charge when it is moving attains a maximum value at it has a maximum rate, which is the maximum current, and at that point the energy is stored completely in the inductor. In the next phase, what will happen? You can guess. The mass will be compressed maximum. It will come to a standstill. From the Vmax, it will reach another stage where it will come to a standstill, which means the mass will now stop. So if you were to show that situation, this is what happens. I'll just draw it quickly, that the mass system will be very close to the wall, and now it is stationary back, it is stationary, okay, it stops, and the spring shows you the maximum compression. The spring is at maximum compression now, and it is not moving again. And similarly, in the context of LC circuit, if you notice, okay, the LC circuit, so if you notice the LC circuit, the complete charge, okay, is back to the capacitor, because there is no movement of the charge now, because the whole current went back and again charged back the capacitor. So the capacitor is now fully charged, fully charged. The capacitor is fully charged. Make sense to you? And the inductor has no magnetic field energy left. And this is the exact situation now. Okay. So whenever the charge is stationary, it corresponds to potential energy, right? Which is electric field. So there is no energy here now. No half Li square. So half Li square is equal to 0. And the complete energy is stored in the form of electrostatic energy. All right, so the charge is stationary, and here the complete potential energy is 0 on the right hand side in the spring block system, and the velocity is 0, so the kinetic energy is 0. Half mv square is 0, and the spring is fully compressed, so the complete energy is half kx square. This is where the energy gets stored when the spring is fully compressed now. Now the spring will again start going back. It will again go back to the mean position, which means the energy will get completely converted into kinetic energy, and then which means energy will reach here. So the answer is the inductor corresponds to kinetic energy, and the capacitor corresponds to the potential energy of the spring block system. So the oscillation in a spring block system and the oscillations of charge, it is the charge which is oscillating in the LC circuit, are equivalent of each other. You can watch my videos. LC oscillations are very, very important as a topic. Please go through my playlist that has complete explanation. I think it's under the alternating current or wherever it is. Do study LC oscillator. You can expect questions, and also you must know about this. It's a very important circuit used in practical life also. So thank you very much for your time, and wait for my next video. This was from NCERT model paper published on the NCERT website. I hope you enjoyed it. If you did, do like it.